Hello everyone, I am Martin Cronenberg. Today I would like to introduce you to two estimation methods that have proven themselves in practice. Before that, I'll show you that you need to distinguish between effort and complexity when estimating and why you should know the speed of a team and the Fibonacci numbers. Why do we estimate at all? We estimate because the project managers have to plan a project. To do this, they need to have an idea of what technical content can be implemented in what time and with what budget. They obtain this information with the help of estimates. Generally speaking, an estimate is a function that assigns a value from a total ordered quantity to a so-called estimation item, the so-called estimated values. Such an estimation item can be any artifact that is used to capture the wishes of the customer and/or the end user in a project. Typical estimation items are user stories, features, epics, or requirements. We need the total order of the estimated values in order to be able to compare individual values with each other. As a set of estimated values, the natural numbers come into question. The subset, your 0.5, 1, 2, 3, 5, 8, 13, 20, 40, 100 based on the Fibonacci numbers is used very frequently. The so-called t-shirt sizes are often used: XS, S, M, L, XL, XXL. We describe an estimation method as effective if it has proven itself in practice in a specific context. With an estimation method, we can estimate various aspects of an estimation item, for example, complexity, effort, risk, benefit. Here we focus on the two aspects of complexity and effort. You can have experts estimate the cost of an estimation item in person days. These experts must take at least three aspects into account. How complex is the content of the estimated item? Who should do the estimating? An experienced person or a novice? When should this person implement the estimation item? Immediately or later, when other prerequisites may exist, or the person has built up knowledge. In practice, however, it has proven useful for the team to only estimate the complexity of the estimation item depending on its content. The effort can be derived with the help of the team's velocity. In the following, we assume that we have user stories as estimation items. This simplifies the way we speak. However, the following also applies to other estimated items. In this approach, highlighted in green, a team estimates the complexity of a user story by comparing its complexity with the complexity of user stories that have already been implemented. At the beginning, the team agrees on a user story with a story point, the so-called reference story, something like an original meter. Experience has shown that people can make relative estimates more easily and quickly than absolute estimates. That is why we use such reference stories and analogies. The velocity of a team indicates how many story points a team completes in a given time. We usually look at a sprint. We determine the speed based on the story points that the team has implemented in the previous sprints. If the team composition remains the same, the velocity should increase over the course of a project as the team learns. We explain the relationship between complexity and effort using an example. We assume the following conditions. The team consists of 5 people. The specified time is one sprint, which comprises 2 weeks, that is 10 working days. The speed is 40 story points per sprint, or 4 story points in 1 working day for the entire 5-person team, or 4 5-story points per person day. In the first example, we look at a user story with a complexity of 8 story points. For this user story, this results in an effort of 1/5 of a sprint, or an effort of 10 person days. In the second example, we assume that a team member is on vacation during a sprint. This reduces the available capacity of the team to 4 people. The speed of the team is reduced to 32 story points per sprint. Always assuming that we have a linear relationship between the capacity and speed of the team. We said above that a modified Fibonacci series is very often used, but why is this done? Experience shows People can and want to estimate small sizes quite accurately. However, the bigger something gets, the more uncertain people become about estimating it. The Fibonacci numbers fit in perfectly with this experience. The small Fibonacci numbers allow even small differences to be differentiated. The larger the Fibonacci numbers become, the greater the distances between them. For example, no one would want to differentiate between the numbers 18, 19, 20, 21, or 22 when estimating, but they would between 20 and 40. And why not use the correct Fibonacci numbers, 21, 34, 55, 89, etc.? We obviously prefer to work with, in quotation marks, round numbers such as 20, 40, and 100. Building on these foundations, we now present two estimation methods that have proven themselves in practice: planning poker and magic estimation. We assume for both estimation methods, there are a lot of user stories to estimate. There is an estimation team of several people who estimate the user stories. There is one person who is technically responsible for a user story and presents this user story to the estimation team. We call this person the story owner. In a Scrum context, this is usually the product owner. For estimating, we have sets of cards with the possible estimated numbers. The planning poker procedure is as follows. Each team member takes a set of cards with the modified Fibonacci numbers. The story owner briefly presents a user story and the team asks comprehension questions. Everyone places the card with their guess face down in front of them. Then everyone turns over their card at the same time. If all estimates are the same, this is the result. Otherwise, the team briefly discusses the runaways and estimates again. After a maximum of 3 estimation rounds, the highest estimated value applies if no consensus has been reached. This estimation method has proven itself in practice in the following context. The estimating team is not too large and consists of a maximum of 10 people. The number of estimated items is rather small. That is less than 20. The procedure for the magic estimation method is as follows. The story owner records the user stories on slips of paper and distributes them evenly to the team. On the floor or on a table is a deck of cards with the modified Fibonacci numbers. Each person in the team assigns their slips of paper to the numbers. Each person then silently looks through the other pieces of paper. If you assess a user story differently, you move the piece of paper and mark it. At some point, everyone has read all the slips of paper. Stable slips of paper, that is without markings, are taken out by the story owner and their estimates are noted down. In a second phase, the team discusses and estimates jumping slips of paper, that is with markings, openly or estimates them using planning poker. This estimation method has proven itself in practice in the following context. The estimation team consists of any number of people. Even more than 10 people are possible. The number of estimation items can also be very large. Even 100 or more, estimation items can be estimated well in a relatively short time in this way. Planning poker and magic estimation provide estimated values for the estimated items as a result. The team also discusses the content of a user story with the story owner. This is very helpful for a common understanding within the team. Finally, here are a few best practices to help you on your way. Estimate as close as possible to implementation. If you value a user story large, equal to or greater 13, you should split it up. As the project progresses, define reference stories for the other sizes in addition to the reference story for one story point. Important: everyone in the team must know and understand the reference stories. Always remember, the result of an estimation method is an estimate. The actual value may differ. No one is guilty of this. You must try to learn from it. Estimate effort and benefit, and combine both pieces of information using the weighted shortest job first, WSJF method. See section 1.7. You now know 2 estimation methods with which you can effectively and efficiently arrive at an estimation result in almost all situations. Try them out.